Hey class, in today's lesson we're going to talk about inverse relations and functions, which is found in 6-7 part 2 of your book. We're going to find the inverse of a relation or a function. Alright, so in example 4 we're going to find an inverse function. So it says consider the function f of x equals the square root of x minus 2. What is the inverse? F, that's basically f prime or f negative 1 of f. And then is the inverse a function? So this second question I want you to realize is going to be a pre-AP question. So if you're watching this video and you're in my regular class, ignore the second question. Alright, so it says consider the function, what is the inverse? Okay, we know that we need to switch. Now this is just basically telling you that this is another notation for inverse. So notice we have f of x and f negative 1. So that's the same thing as just your, basically it's being stated as the inverse. Okay, so f of x will replace with y as the original. So y equals the square root of x minus 2 is the original. So when I switch, I'll have x equals the square root of y minus 2. Okay, we're going to solve for y. So we need to square both sides. We'll get x squared equal to y minus 2. Then we add 2. And we will get y equals x squared plus 2. Alright, so now if you're in my pre-AP, let's go to the question, is the inverse a function? Okay, so the original, first we need to figure out what the domain and range is. So I'm going to give a quick sketch of that graph. It's minus 2, so it's been moved to the right 2, and it looks like that. Okay, notice this doesn't say plus or minus, it's just the positive, so it's just the positive part. So the domain here would be all real numbers greater than or equal to 2. Okay, and the range would be all real numbers greater than or equal to 0. So when you find the inverse, okay, they switch. Alright, this we know is a parabola, right? X squared plus 2 is a parabola, so it's been moved up 2, and it looks like this. However, when you do that, the domain and range switch position. So the domain now is supposed to be all real numbers greater than or equal to 0. And the range is supposed to be all real numbers greater than or equal to 2. Alright? And specifically here, it looks weird to say that the domain is all real numbers greater than or equal to 0, but it is because it was restricted in the beginning, and now it's not so much. So this is your actual domain. So with saying that, it says, is the inverse a function? And so in this case, we can obviously tell that even if we did a vertical line test on this graph below, right, that it would be considered a function, okay? However, the way we will state this is that the inverse is a function, but specifically when x, and I really should have used x and y, so I'm going to go back and change that to an x, make this a y, make this x, make this y. Okay, so the inverse is a function as long as x is greater than or equal to 0. Okay, because we won't say all real numbers here, once again, because it was restricted from the beginning. Okay, we're going to try another one because I know that sounds really confusing, so let's do the next one. So it says, consider the function g of x equals 6 minus 4x. What is the inverse of g? Is it a function? Okay, so the original is g of x equals 6 minus 4x. Okay, the new function would be where g of x is really supposed to be y. We're now going to say that's x equals 6 minus 4y. Okay, we're going to get y by itself, so we're going to subtract 6. That will give us x minus 6 equal to negative 4y. Divide by negative 4. So this will give us y equals negative 1/4, oh my goodness, negative 1/4 x minus 3/2. Alright, so let's rewrite this original one also. This would really be g of x equal to negative 4x plus 6, just so that we can see it in slope-intercept form. Alright, so that original domain, just as a quick sketch, that graph would have been up 6, and it would have been negative, so it would have done something like that. Okay, and this new one down here would have started somewhere negative, and it's also going to be down here, but it's a little bit more slanted. Okay, it's really not so difficult here for domain and range, because our domain would be all real numbers, and our range is also all real numbers. Okay, and then so here for our domain and our range, they would switch positions, right? There's no restrictions here, so it's still all real numbers and all real numbers. So yes, it is a function. So the inverse of g, or g negative 1, is a function. Let's keep going. All right, so at the top you see a chart, and so it basically says that the domain of f will be the range of the inverse, and that the range of f will be the domain of the inverse. So domain and range, when you want to think about them like that, they are interchangeable. So it says, recall that each x value in the domain of a function f corresponds to exactly one y value in the range. So for a one-to-one function, it is also true that each y value in the range corresponds to exactly one x value in the domain. So a one-to-one function f has an inverse that is also a function, and if f maps a to b, then the inverse must map b to a. So that's just basically talking about a one-to-one function. All right, so now we're going to do compositions of inverse functions. We've already kind of talked about compositions. I'm going to apologize in advance. This system that I use does not have the little tiny o to show true composition, but it'll still get the job done. All right, so the first one, it says, what is the inverse of f of x? So f of x, remember, if we rewrite it, is really y equals 6 over x minus 2. So to find the inverse, we need to switch positions. So this is really x equals 6 over y minus 2 right now. We need to multiply both sides by y minus 2. And so, and then we want to and then while it's still like this, or actually I should rewrite it. So this is x times y minus 2 equal to 6. Okay, now we want to get y by itself, so I need to move the x first. I'm going to divide by x. So I'm left with y minus 2 equal to 6 over x, and then I'm going to add 2. So y, or the inverse of x, or the inverse of f, sorry, equals this. All right, so then this says, or should say, f of the inverse of 2. So remember, when we do this, we work backwards. So 2 goes into the inverse, and then whatever the answer is from the inverse, we put back in f. So if I put 2 into the inverse, that would be 6 over 2 plus 2, which is 3 plus 2, which equals 5. And then I'm going to take this answer and put it back into f. So if I put 5 in there, I would get f of 5 equal to 6 over 5 minus 2, which would be 6 over 3, which is then 2. So 2 would be the final answer there. Okay, let's do the second one. And again, this one is saying 2 goes into f, and then whatever that answer is goes into the inverse. Okay, so I'm going to kind of break this up a little bit. If 2 goes into f, that would be f of 2 equal to 6 over 2 minus 2, which is really 6 over 0, so this is undefined. And since this is undefined, this is as far as we can go, so we would stop here. All right, let's try the next one. So it says, let g of x equal the function below. What is each of the following? All right, so we need to first rewrite this as y equals 4 over x plus 2. That way we can see it a little better. All right, so to find the inverse, this then becomes x equals 4 over y plus 2. Okay, we're solving for y, so we're going to multiply both sides by y plus 2. So now we have x times y plus 2 equal to 4. Then we're going to divide by x. So we have y plus 2 equal to 4 over x. Then we subtract 2. So g, or the inverse of g, equals 4 over x minus 2. Alright, so then if I do the composition, I'm going to put 0 into the inverse and then that answer back into g. So if I put 0 into the inverse, that'd be the inverse of 0 equal to 4 over 0 minus 2. That first part is undefined, so we would stop here. This is just undefined. Alright, so then if we do the last one, we would put 0 back into g and then that answer back into the inverse. So if I put 0 into g, that'd be g of 0 equal to 4 over 0 plus 2, which is really 4 over 2, which is 2. Okay, we'll then take that answer and put it into the inverse. So the inverse of 2 will equal 4 over 2 minus 2, which is 2 minus 2, which will equal 0. So 0 is the final answer on that one. Alright guys, we are done with this section. Remember, if you have any questions, please come see me for tutoring.